Welcome to Ask and Learn.
In this problem, the face of a person is slapped, and for a specified temperature increase of the affected part, we wish to calculate the impact velocity of the hand. The assumptions we make is that the hand is brought to a complete stop after the impact, and the face takes the blow without significant movement. No heat is transferred from the affected area to the surroundings, and the process is therefore adiabatic. No work is done on or by the system, and the potential energy change is zero. So we'll identify the closed system, which is the hand and the affected portion of the face. And we also observe that the kinetic energy of the hand decreases during the process, since we have a decrease in velocity from the initial value to zero. So while the internal energy of the affected area increases, there's an increase in temperature, and there's no significant energy transfer between the system and its surroundings. So we can write the energy balance equation as E in minus E out is equal to the change of energy of the system, delta E. Now there is no net heat transfer or no work done on or by the system, so the left-hand side is zero. But we have a change in internal energy, delta U, and that's the change in internal energy of the tissue on the face, plus the change in kinetic energy, delta KE, for the hand. So basically what we can see from this equation is that all the kinetic energy from the hand is transferred to the tissue of the face. So we can write this, we can expand these as mc delta T, the change in temperature, we see the specific heat capacity of the tissue. I'll use T for tissue, plus the change in kinetic energy is a half m into 0 minus v squared. And we'll use subscript h for hand. Now this is our energy balance equation. So the decrease in kinetic energy of the hand must be equal to the increase in the internal energy of the affected area. So what we can do from here is rearrange this equation and solve for v. So v is the velocity of the hand initially before it strikes the face, which is what we want to calculate. And this, if we rearrange this equation, is 2 mc delta T for the affected tissue over the mass of the hand, mh. So since we know these values, we can substitute them in and we can find the velocity of the hand at the moment of the slap. So that's the square root of 2 into the mass of the tissue, 0.15 kg, multiplied by its specific heat capacity given as 3.8 kilojoule per kg degrees Celsius, times a temperature change of 2.4 degrees Celsius at the affected area. This is all divided by the mass of the hand, 0.9 kg. Now these are all in SI units, so we get our answer in SI units. And we get the velocity of the hand to be 55.1 meters per second. And for more context, we can write that in this form as 198 kilometers per hour.